Gene Schriefer, Ag Educator with University of Wisconsin-Madison Division of Extension. I'm out in Iowa County and I work with the local watershed group. And today we are demonstrating some of the tools that are included in the soil health test kit. This is an old piece of irrigation pipe. It's about 6 inches in diameter. We're going to insert this in the soil approximately half the distance, so about 3 inches or so. Because it's made out of aluminum, we also give you a high quality block of wood. And with this, we're going to put that on top and then also have a rubber mallet, which will allow you to pound that into the soil to the appropriate depth without bunging up this edge and peening that over. So I've put that in as evenly as I possibly can, and I've pulled out some of the excess debris inside the infiltration ring. So we've got our ring here. And then we have to add the equivalent of about 1 inch of water. Now, we've recently had rain. If we haven't had rain in the last few days, we would normally wet this first and allow that to sink in. Once there's no more water present, then we're going to measure and time that second application of water. So for 6 inches, 1 inch in a 6 inch circle translates into about 444 milliliters, and I've got it marked. I can see that on my graduated cylinder, but that's how much water is the equivalent of 1 inch in a 6 inch ring. Now we're going to and we are at 444 milliliters. Now, one of the things that we also do besides removing debris is we're going to just put a small piece of plastic wrap. This is also in your kit. And this is to really, we're trying to get a true measurement of what it might be for rainfall. We don't want to disturb the soil by dumping this in very hard or very fast, because that might disturb the soil and influence the rate of infiltration rate. So we're going to put this in gently, remove that, and then we're going to have a stopwatch. Our water infiltration test begins by dumping that in, 440 milliliters in that 6 inch diameter, and then we're going to pull that and then hopefully quickly turn on the stopwatch, and we're going to say stop. See that entire 1 inch equivalent of water infiltrate. We're going to call this done, so I'm going to hit stop. And what we're looking for is where we can see that the soil surface is kind of wet and glistening. There shouldn't be any pools or puddles of water. In this particular case, we're showing about 5 minutes and 21 seconds for that water infiltration rate. So we could take that information and we could actually calculate what an inch per hour rate would be. In this case, I haven't done the calculations, but my guess is this is going to turn out to be about 5 to 6 inches per hour in a water infiltration rate, which should take care of most of our bigger storms. It's not going to take care of our 17-inch rainfall, but this farm is going to capture and store a lot more water than one that might take 10, 15, 20 minutes. And I've seen some where the water hasn't infiltrated after 25 minutes with just a single inch of water. So more infiltration rate is good. This will depend on your soil type and as well as your management. So sands inherently drain faster. We're on a silty loam soil here today with a clay subsoil. This is really a great soil for holding water and giving up water for crops, and it has a moderately good water infiltration rate.
I'm Landon Baumgartner. I'm the conservation specialist here for the Iowa County Land Conservation Department here in Dodgeville, and we are doing a soil health kit field test today, which includes a test known as the slake test, and we're going to be demonstrating that here. What this test is used for is to show how the structure of a soil is what the quality of the structure of soil is, and basically it can be done with this little net cup here from a regular sink drain and a cup of water. And what it basically does is it looks at how soil is going to behave when water rushes into the pore space that is in a soil sample. So a healthy soil will more or less hold up under the pressure of a massive amount of water rushing in to fill those pore spaces as water does. And if it's a good and healthy soil, all the natural biological glues such as glomalin will be able to make sure those pores stay intact and not collapse so much. Here we are in a perennial grass pasture setting. So it may look a little bit different based on the type of land that you are going to be doing the test in. But essentially what we have here is a silty loam soil that has been placed in this cup. And as you can see, there's a little bit of dissipation of particles falling out of this bed that we have, but more or less the structure is staying relatively intact. If we were in an area that was more conventionally operated, undergoing a lot of tillage or a lot of mechanical disturbance, we'd probably see that water sample get a little bit more cloudy, as well as if it were a differently managed system, we may have it be even clearer yet. But this is just a way that you can evaluate what your soil structure is like and how it will behave under pressure from water.